Hey everyone, and welcome. Have you ever wondered what exactly happens between a developer finishing some code and that smooth, bug-free app actually landing on your phone? Well, today we're going to pry open the Software Tester's Toolkit and take a look inside.
So, just imagine you're a developer. You've just pushed out a brand new, brilliant feature. The code is officially live. But there's always that little nagging question in the back of your mind, right? Is it actually going to work for everyone? And did I accidentally break something else in the process? That's exactly where software testing comes in.
So we're going to explore this whole world by looking at it like a real toolkit. We'll pull out the specific tools, the techniques, and even the philosophies testers use to make sure everything works perfectly. First up, let's look at the tools for those first crucial checks.
Okay, so a brand new version of the software, what the pros call a build, has just been created. Now, before you can even get excited about all the cool new features, you have to ask a much more basic question. Does the thing even turn on? Let's check out the tools for that initial critical step.
The very first tool we pull out of the bag is called smoke testing. The best way to think about it is like walking into a house that's just been built. You're not going to go around checking every single power outlet right away. Nope. You just find the main light switch and you flick it on. If the lights come on, awesome. The basic electrical system works. If they don't, well, there's no point checking anything else, is there? That is a smoke test. It's a quick, broad check to see if the most important stuff, like logging in or just launching the app, are even working at all.
Now, this is a super common point of confusion, so let's clear it up. Smoke testing is broad and shallow. You're just lightly checking the whole new build. Sanity testing is the complete opposite. It's narrow and deep. It usually happens after a specific bug has been fixed, just to make sure that one little repair actually worked and didn't break anything right next to it. So think of it this way. Smoke testing is for the brand new house. Sanity testing is for checking the one leaky faucet you just fixed.
All right, so the new build passed the smoke test. It's not on fire. That's a great start. But the next huge challenge is making sure that adding that cool new feature didn't accidentally break an old one. And this is a big deal, because this is how a simple update can turn into a total disaster for a company. This next tool in our kit is all about protecting what was already working just fine.
And that brings us to regression testing, which is, without a doubt, the absolute safety net of software development. See, every single time a developer adds something new, they risk this ripple effect that could break something totally unrelated on the other side of the app. Regression testing is what stops a simple update to your banking app from, say, breaking the transfer money button. Its entire job is to prevent progress from causing, well, regress.
And this chart just lays out the difference so beautifully. Take a look at the scope. Retesting is super simple. A bug was found, a fix was made, and now the tester retests that one specific thing to make sure it's fixed. It's focused on what failed before. Regression testing? It's the opposite. It focuses on everything that used to pass, just to make sure it still does. One confirms a fix, the other prevents a catastrophe. So far, we've mostly talked about the specific actions testers take, but now let's kind of zoom out a bit and look at the two fundamental mindsets or philosophies that really guide their work. It's all about the perspective they bring to the job. Okay, let's do a quick thought experiment. I want you to imagine the software is just a completely sealed black box. You have no idea what gears or wires are clicking away inside. All you can do is put something in one end and then see what comes out the other. You're basically testing it from the exact same perspective as a normal user. Just keep that image of a sealed box in your head for a second.
So that sealed box, that's black box testing. The tester has zero knowledge of the internal code. They just test the functionality. If I type in my password and hit enter, do I log in? Simple as that. Now, white box testing is the total opposite. Here, the tester is like a mechanic with the car's hood wide open. They can see all the internal code, the logic, the pathways, and they design tests to make sure every single line of code is doing exactly what it's supposed to. So you can think of it like this. Black box is about the what, and white box is about the how.
All right, in our final section, let's talk about something really important: efficiency. I mean, you can't possibly test every single possible scenario. It would literally take forever. So how do testers get the most coverage with the least amount of effort? Let's look at a few really clever techniques they use.
Let's use a super practical, simple scenario. We've got an input field for someone's age, and it only accepts numbers between 18 and 60. Now, you could sit there and test 18, then 19, then 20, 21, all the way up, but what a waste of time. How can we be smart about this? The first really smart technique is called boundary value analysis, and the logic here is simple. Errors don't usually happen somewhere in the middle of a range. They happen right on the edges.
A developer might have accidentally typed less than 18 when they really meant less than or equal to 17. It's these tiny off-by-1 errors that cause problems. So instead of testing everything, you just intelligently test the boundaries.
And here's exactly how that plays out for our age field. We're not going to test 42 different numbers. Nope. We test these 6, the valid minimum and maximum, 18 and 60. Then the numbers just inside the boundaries, 19 and 59. And, most importantly, the invalid numbers just outside the boundaries, 17 and 61. With just those 6 tests, you get an incredible amount of confidence that the whole range works.
Now, building on that idea is another awesome efficiency tool, equivalence partitioning. This technique basically says, hey, if the number 35 works, then 34 and 36 are probably going to work too. They're all part of the same valid group. So what you do is divide all possible numbers into a few logical partitions and just test one number from each group.
And you can see the power of this right here on the screen. We've basically taken every number you can think and split them into just 3 partitions. You've got one invalid group below 18, so we'll test with, say, 10. You've got the one valid group, so we'll test with 35. And you've got one invalid group above 60, so we'll test with 70. Just 3 tests to cover infinite possibilities. Now that is testing smart.
But you know, not everything can be so structured and planned. Sometimes, the best tool a tester has is just plain old human creativity. And that's exploratory testing. It's totally unscripted. The tester is learning about the app as they're using it and designing new tests on the fly based on their intuition. This is how you find those really weird, unexpected bugs that no formal test plan would ever catch.
Finally, there's a simple principle that really underpins every single technique we've just talked about. Every test has 2 sides. Positive testing is making sure the app does what it's supposed to do, like a correct password lets you log in. But just as important is negative testing, which makes sure the app gracefully handles what it's not supposed to do. And incorrect password should give you a helpful error message, not just crash the entire app. A truly complete test always does both. So as we close the Tester's Toolkit for today, here's a final thought for you. The next time you're using your favorite app and it just works, when an error message actually makes sense, or when a new feature gets added but all the old ones are still perfect, just take a second and think back to these tools. Which one of them do you think just saved you from a crash?